Hello everyone, welcome to the video. And first of all, my project is the basics of neural network and deep learning. So I'm going to show how the neural network works and how we can classify one images by the training the model and the neural networks. So I'm using the database MNIST database. So MNIST database is a database of handwritten digits. So it looks like this, as you can see. So the digits are derived from 0 to 9, and in the database these all are handwritten. So we have to predict by the neural network. We will give one single image of any one of these digits, and our model will be able to predict like what digit it is after all the training and after till the end. Okay, so let's get started. And first of all, to do that, we will import the libraries, and also it is we are going to use Python code, and I'm going to use the library framework, Google's framework TensorFlow, for this machine learning, deep learning. And this interpreter is currently Google Colab I'm using. And also you can use Jupyter Notebook or any other Python interpreter. That is no issue in that. It is just uh, looks good, nothing else. So we are using Google's TensorFlow and Keras. So first of all, we will import all the required libraries, and then I'll run it. And now I'm going to load my MNIST database. So as I've told that we are using TensorFlow, and TensorFlow already has this basic all the databases. So we can just import TensorFlow.ks.databases.mnist and into the variable, and from that variable we have to just call one method or function, and this function will return these tuples, like xtrain, ytrain, xtest, and ytest. So currently our xtrain and ytrain is currently my xtrain will be this images, and ytrain will be what are the answers of these images. So for this images my answer is 0. For this images my answer will be 3. For this images my answer will be 7. So it is not answer, but we can say it label. For this images my label will be 8, and likewise. So that is my ytrain, and that is, and another value it will return is xtest and ytest. So what are xtest and ytest? These are just for after testing purpose. So after training my neural network on xtest, xtrain, and ytrain, I will try to predict. I will try to check that what the my neural network has learned. And if I try to ask some questions, so I have to ask some unknown questions. So these are unknown images, and these are the labels to check like are they true or not. And then for that I will load this. So it has everything. So it has loaded the data, and then reshaping my matrices. So reshape after reshaping my what is my extent of shape 0? That is the number of images, and then this is the dimension of images. Okay, 28 cross 28 cross 1. So I'm reshaping all the images. Currently I have not validation data, so I'll remove this. And by reshaping, my dimension will be, if we can check, then my x train shape will be uh, like 60,000 images, and 28 total number of images are is 60,000, and the dimension of one images is 28 cross 28 cross 1. And this is number of row, number of column, in the number of pixels in one row, number of pixels in one column, and then total number of channels. So if it is a color image, then it will be channel will be 3 RGB, but it is black and white image. So as you can see, so it is just one. Okay. So and also my white rain, what my white rain looks like. Okay. So y train. So if I try to print it, it will print all, sorry, wait, it will print all the labels like 504 and up to and okay. So these are my labels, as I was just told that for one image is this is the its answer, for that image this is the answer. Okay, so this is my white line, but for the to training purpose we need to convert it into one another form. The answer will be the same but the form will be changed, so that is known as the categorical form. And to convert the my labels into the categorical form, I will do this like my white line, and I'll convert it into my categorical form. So this is a category. After converting to categorical, so we'll do it like this. Our xdate extend to categorical, and I'll give it my extend and total number of images. This is my total number of class. So my total number of class is 0 to 9. So total 10 classes. Okay, so this is 10, and I'll run it. So now my white line will be okay. My white train, then my white train or whitest, it will be in this form. Okay, so like we can see, for 0, I will print only one of them, so we can have some good idea. Okay, so this was 5. So currently this was 0, 1, 2, 3, 4, and 5th. It is on 5th position. Okay, and then means this position is 1, so it is on 5th position. So this is 5. Okay, then if I check for second, then it is 0. So on 0th index there is 1. Okay, for second, it is 4. So on fourth index it will be 1. So 0, 1, 2, 3, 4. Okay, so this is the categorical form. Okay, so the answer are same but the representation is different. And then we are trying to reduce the complexity. So we are reducing the complexity by dividing the number, so that the number will get reduced. So currently our color value, all the color values are between 0 to 256, maximum 256. 256 means white and 0 means black. So by dividing with all the values with 256, what will happen is all the value will be now converted in between 0 to 1. So my all the values of x train and all the matrix values will be between 0 to 1, and 0 is black and 1 is white in this case. So now my complexity will be reduced of the all the multiplications complexity. Okay, so I executed that, and then I'm currently making my model. So I'm for model I'm using sequential. So sequential because in sequential model all the layers will be executed one after one. So I'm using this sequential model, and in that model I am currently adding one flatten layer. So flatten, what the flatten layer will do is if I will give it 2 cross 2 matrix, like 2 cross 2 matrix with values 1, 2 and 3, 4. So it will be converted it to 2 cross 2 matrix in 1 cross 4, or we can 4 cross 1 row in one single row. So it will be 1, 2, 3, 4, not 1, 2, and in second row 3, 4. All everything will be in one row. Okay, everything will be appended. Everything row will be appended after upper row. Okay, so this flatten layer will do this. And in the I have created one basic neural network with 128 neurons in first layer, and in second layer there are 10 neurons. So my second layer is my output layer, and this is my first layer. Okay, so in first layer my input shapes is 28 cross 28 cross 1, because my one single column, after flattening one single all the matrix will be converted into one single row. So well, in how much numbers are in that row, so there are total 28 cross 28 cross 1 numbers. Okay, and then activation and softmax is the one other thing. Okay, we don't need to know about that. and then we are now compiling a model. So we have created the model and now we are compiling the model. Okay, so to compile the model we are using Atom Optimizer. The optimizer will reduce some complexity in some context. Okay, and then there is a loss, and it is categorical cross entropy, and there is metrics which are accurate, because we are concerned about the accuracy, so we will get the accuracy matrix. Okay, now I'll compile my model. After compile, let's just summarize the model. So to do that, first we will build the model. Okay, so okay, we have to give input shape. Input shape is over 28 cross 28, and that is one row. Okay, so this is model build, and now we will check for the summary. Okay, so this is my basic model. First I'm flattening, and there is no parameters are going to be changed. Then currently my first dense layer, so this is first dense layer, and my output shape will be this, and then my second dense layer, and the output shape will be this. Okay, so this is my basic neural network. Okay, and now I am going to fit my model. So the by this line I'm going to teach it. I will show this model dot fit will show my neural network one image, then try and tell him that learn this image, and then it will show that this image is of number 4, so you have to learn it, then it will do it repeatedly. And there are 5 epochs. So in my trained dataset there are total 60,000 images, and I'm giving 5 epochs. So what is epoch? Epoch means a number of times my neural network will go through all the images. So epoch is 5, means 5 times my this neural network will go through all 60,000 images. Okay, and these are validation speed. So validation data to validate how the model is going to learn, how model is learning in every epoch. And this is there is some incompatibility. We'll check what it is. Okay. So I have figured it out, and now we'll run it again. And yes, so we can also give validation. So the 0.1% of the images will be considered as the validation images. Okay, so that's why there's point 1. And okay, so here we have to convert our loss function, which is sparse categorical cross entropy. Okay, so now our model is fitting. So in this phase, all the images will be shown to the neural network, and neural network will try to learn all the features of the image, and then it will be tell him that if you get this kind of structure, then it is this digit. If you get this kind of structure, then it is this digit. Okay, so this way the neural network will get learn uh, what image will called what digit. And now we will try to evaluate this. So to evaluate, I will give the testing data. So this data my neural network has not seen till now, and to check and so in this phase it will get this data, these images, and predict the label for this image. and then this is the original label, and it will check that if this predicted label and this original label are the same. If they are same, then the prediction is correct. If they are different, then the prediction is wrong. Okay, so based on that we can get some accuracy. So in this training phase we are getting 94%, 94.52% of accuracy, validation accuracy. So this is the our main concern, validation accuracy. Okay, so so basically validation is in each epoch we are trying to test that how our in which way our model is learning. Okay, so now I will evaluate this, and my actually accuracy on test data is 93.54%. Okay, so now I will try to predict that, manually predict that. I manually predict my label of X test, and all the predictions will be saved in the predictions variable. Okay, so in this all the images will be shown to the my neural network, and my neural network will in output my neural network will generate some what do we say, some labels. Okay, based on the image. So if it thinks that it is 2, then it will generate 2. Okay, in the predictions. So predictions are now I want to check like what it has predicted for image number 0th image. Okay, what it has predicted number 7. So to verify that, I can check also, like I have test images and I can show a 0th image to image, and now I can plot that image. So on 0th image it is this kind of structure, so it has predicted it is 7, so it is true. Okay, now I can say like of 100th image what it has predicted. So it has predicted 6, and so to verify this we can also check what is the 100th image on the test data. Okay, so this has this kind of structure, so it is also like true, it as the prediction is true. Okay, so this way we can construct our neural network. It is very simple method, and we can also learn so many tutorials are there for the TensorFlow, or you can also use the framework TensorBoard, which is backed by Facebook also, and that is also one very good framework. Okay, so this way we can generate all this thing, and thank you for watching. And one more thing, I've created all this and put it on the GitHub, and you can check it out if you want. Okay, so on my GitHub I've created it. Okay, fine. Okay, thank you.